In this video, you will learn how you can tell if a function goes up or down, stretches or compresses, goes left or right, and whether it reflects over the x or y axis just by looking at it. It all relies on memorizing the parent function, which I have pictures of in the middle. The linear parent function is f of x equals x. The quadratic parent function is f of x equals x squared, and the absolute value parent function is f of x equals the absolute value of x. The next step is to get familiar with the different types of transformations. If you see x plus another number in parentheses, then the point on the graph will slide that many places to the left. If you see x minus another number in parentheses, then the point will slide that many places to the right. In contrast, if you see x plus a number outside of parentheses, then the point will slide up that many places. And also, if you see x minus a number outside of parentheses, then it will go down that many places. To determine if the line reflects over the x or y axis, it all depends on whether the negative sign is in or outside the parentheses. If the sign is inside, then it reflects over the y-axis. If it is outside, it reflects over the x. Finally, you can see if the new function stretches or compresses based on the value of a, the number x is multiplied by. If a is greater than 1, then the new function will stretch, and if a is greater than 0 but less than 1, then the function will compress. Now, let's try some examples. In a linear equation, the table of the parent function always looks like the one in the top left corner. So if you get a new equation such as f of x equals x minus 4, then you can either simply add 4 to all the x values in the table and graph them, or draw out the parent function and move every point on the line 4 points to the right. Next, with this quadratic equation, I already made the table for the parent function, and the new function is x squared minus 2. So, from what we have already learned, you hopefully know that this simply means that every point on the graph is going to go down 2 units. However, if you still don't know that, simply subtract 2 from all the f of x values, and then graph the points. As you can see after graphing, the line is exactly the same, just moved down 2 places. Now we will try another example of stretching. We already know that the new function stretches by a factor of 2 because of the 2 in front of the x. So all you have to do is multiply the f of x values by 2 and graph. Notice how the graph stretches and gets skinnier. Let's try graphing an absolute value function. The parent function and table for the absolute value is already up there. The only difference between the parent function and the new function is that there's a negative sign outside of the absolute value brackets. Recall that this means that the graph reflects over the x-axis. So you can either count how far up each point is in the parent function from the x-axis, or you can multiply each value in the f of x column by -1. After graphing, you can see the two functions are exactly alike except they are reflected, similar to looking into a mirror. One reason why memorizing parent functions and transformations is so important is so you can easily graph equations like these without a calculator. We already know that the negative sign means that the new function will reflect over the x-axis. We also know that the 2 in front of the x means that the graph will stretch by a factor of 2. The -4 inside the parentheses means that the points will translate 4 to the right, while the -2 outside the parentheses means that the points will go down 2. Another reason why it is important to know transformations is because they are everywhere. Whether you're trying to determine how far your plane translates north, south, east, or west on a flight, you're studying how a butterfly's design is perfectly reflected on its wings, or how to draw a floor plan of a house and then build it to scale.